Hello, this is our worksheet on moles, and a moles is somewhat mathematical with the concept of mole. So we want to solve this worksheet here. So first, one question. Question number one, short questions. See the first one. One of one. The number of atoms in one molecule of this. So the emphatic word. How many atoms? And in one molecule. So this question is not about moles. This is one molecule, like one person. You are a person. So if this is one molecule or one particle, then how many atoms it consisted of? See here, 3, 4, 5, 6, 7, 8, 9, 10. So answer to this question is just 10. So you write 10 atoms. Simple, very simple. Here, nothing about mole. So the next question, the number of potassium ions, a number of moles. This is important here, moles. The previous one was not mole, this was number of atoms. Here is number of moles of potassium ion, K plus, in 1 mole of potassium carbonate. So what do you have here? 1 mole of K2Cr2. No, this is carbonate, potassium carbonate. Okay, or potassium carbonate. If this is 1 mole, and you already supposed to know what does the 1 mole mean? Avogadro number, right? 6.02 into 10 to the power 23. This number of what? This number of potassium carbonate. I write here again, copy and paste. This is number of this, and this is here 10 to the power 23. And this is number, right? Number. And get here the formula. In the formula, potassium is double, right? Here this consists of potassium and carbon. Potassium in double. If you have one particle like this, in that one particle, you have potassium 2, right? Like one person has 2 hands. So if this is a one particle, single particle, then potassium alone is double. And if you consider this is 10 particles, how many potassium ion to be there? Double means 20. Is that 10? No. If this is here, this number of particles. So if this is this number of particles, how many potassium ion to be there? Only potassium ion. This is simply double, right? Double of the number. This is what? This is the potassium ion alone. Potassium ion alone. This is number of potassium ion. But is the question is about how many potassium ion that we have calculated? No. The question says how many moles. But we got how many ions? Look carefully. This number of ions, this is a double of Avogadro number, means 2 moles. Okay, 2 moles of potassium ions, right? 2 moles of potassium ions. So this is the answer of the question. So in 1 mole of potassium carbonate, you have 2 moles of potassium ion alone. Good. Now the next question, the relative formula mass of ammonium sulfate. This you need periodic table. Ammonium sulfate. Here 2 polyatomic ions. I write it here again and put the bracket to avoid mistake. Here's nitrogen, molar mass is what? 14. Molar mass is 14 and hydrogen is 1. And how many hydrogen here? 4. So this is to be multiplied with 4. And this is ammonium, right? This is here together, ammonium. And if you multiply this thing with 2, because 2 is multiplied with ammonium, then you get here ammonium, double ammonium. Then sulfur is 32 Oxygen is 16 into what is here 4. So this is here the calculation. What do we get here together? Together, together need to be calculated. Within the bracket first, I calculate what is get. What do you get here? 18, right? 14 plus 4, 18. Then 18 into 2 plus this 2 again together. These are 32 plus 16 into 4. This gives you 64. Okay, 64. Then what do you get? 18 into 2. 18 into 2 gives you 36. So here is 36, then 32, then 64. 36 plus 32 plus 64. Together we get 132. So this is here relative formula mass. And in a relative formula mass is this. If this is molar mass, this would contain a gram, 132 gram. That's it. Now the next one, number of atoms in one molecule of this. This question is again very similar with the first one because here is nothing about mole. How many atoms in one molecule of this? If this is a one molecule, single molecule, how many atoms here? Simply you get 6 atoms, right? 6 atoms. Okay, no mole is here. Next, number of atoms in one mole of this. This is the stir with the same compound, but here was molecule, one molecule. But is here one molecule? No, one mole. One mole is a big issue. 6.02 into 10 to the power, what is that? 23. This is the number of molecules. Here in previous question you got one molecule, and in this question you get this molecule because it says 1 mole. So how many atoms to be there? In one molecule, in the previous calculation you got, in one molecule you have 6 atoms. Okay, in one molecule you have 6 atoms. And if the molecule number of this, then how many atoms to be there? 6 times. Okay, 6 times then the molecule. That's the answer. And the next, the number of moles of bromide ions in 1 mole of barium bromide. This is like this question we have calculated or estimated. Potassium bromide. Potassium bromide was 1 mole. 1 mole means this number, right? 1 mole means this number. And in this number, potassium is double because this is in formula. So this is similar. If this is 1 mole, if this is 1 mole, then that equals the Avogadro number. That equals the Avogadro number. And in the Avogadro number, bromide will be double. Bromide alone will be double than the number of this Avogadro number. And question is not how many bromide, it's how many mole. So mole will be 2. This is 2 moles. Okay, this is 2 moles. Then we get the next one. One mole of atoms contains a number of atoms equal to, this is just simply Avogadro number because 1 mole of atom, 1 mole of anything, 1 mole of anything means this number of things, maybe atoms or maybe molecules. Then this is relative formula math, very simple. Started with aluminum. Aluminum is from period table you get this 23 as a double, plus here is sulfate. Sulfur 32 into oxygen is 16 into 4. 16 into 4. What do you get here? This gives 46 for aluminum and 32 Oh, here is slightly wrong because the sulfate together is multiplied with 3. The sulfate together to be multiplied with 3, we get here 64. Multiplying with 4, we get 64. Then again, whole content is multiplied with 3. 46. What we get here? 32 plus 64. 64. Together we get 96. And 96 into 3, 288. 288. And if that's multiplied with, added with 46, we get here 334. So this to be its relative formula mass. And next, urea has the chemical formula. Calculate percentage by mass of nitrogen. So what's the percentage of mass of nitrogen? How to get it? How to get it? Percentage of nitrogen alone. So first, you see how many nitrogen here? 2 nitrogen. Here's 1 and here's 1. 2 nitrogen, right? And 1 nitrogen means 14. 2 nitrogen is 14 into 2. This is the mass of the nitrogen alone. And now the mass of the compound together, mass of the compound. What is that? You got the 2 nitrogen again. 14 into 2 plus how many hydrogen there? 4, right? 4 is for 4. Then what's left? Carbon, 12. And what's left? Oxygen. For percentage, this will be multiplied with 10. So what do you get here? 28, right? 28, and that's to be multiplied with 100. 100 divide with, what do you get? 14. 14 into this is 28. So 28 plus 4 plus 12 plus 16. Altogether we get 60 here. 60. And the percentage this time 28. Okay, divide 60 into 100. I get here 46.666. We can write 67. Okay. So this is the percentage of nitrogen alone. Next one, the next portion, dm cube, I mean volume, occupied by 88 gram carbon dioxide. You may estimate the volume from mole. What's the mole? No mole given, 88 gram carbon dioxide given here. So what's given here? Carbon dioxide. Carbon dioxide given here 88 gram. And we can convert this into mole, dividing with this molar mass, so we get 2 mole. And then 2 mole equals what volume? If the molar volume is 24, then we get here 48. So this is the dm cube. Simple. The mole of atoms in 2 mole of this. 2 mole of this. When this is 2 mole, then how many molecules there? Here's 2 mole. But if you calculate or estimate number of molecules there, how many molecules? In Avogadro number, 6.02 into 10 to the power 23, right? This is the number of molecules. So here you write in 1 mole, this happens for 1 mole, but question says it's 2 moles. So I need to multiply with 2, right? 2 moles, the 2 moles. 2 and this is mole. Mole means the number, this number. So this is, here you get the number of molecules. But question is about atoms. So now see here, how many atoms here in 1 molecule? You don't have 1 molecule, you have this number of molecules. But how many atoms in this number of molecule. Here estimate 3 here, 3 to the 6 and 2, 8. So 8 atoms in one molecule, right? 8 atoms in one molecule. So if you have this number of molecules, that you have here, this number of molecules, so atoms will be 8 times. Atom will be 8 times of this. So this is the answer. Now the next one, number of mole of lithium ions in 1 mole of this. So this is 2. We have already got one very similar like this. If this is 1 mole, then lithium is double mole. The volume in cm cube of 4 mole of oxygen gas at room temperature. Volume can be estimated from mole. The mole is given here 4. 4 into 24,000 this time, because the question talks about cm cube. So this is the answer. Okay, calculate and multiply, get here. So this is the second question number 2. The combustion reaction of propane with oxygen is represented by the equation. Here you see the equation. This compound has a name. It's propane. It says the Constant propane burns in oxygen to give carbon dioxide and water. And here you get a value of del H. Del H means heat change, that you learn later in details. Heat change here. Okay, as you burn, so heat will produce, and this the heat produce kilojoule. This amount of heat is produced for 1 mole. This is called per mole. I mean, burn 1 mole, get this heat. This means this. And here is that 1 mole compound. Now look at the question. 200 cm cube. This is the volume of the gas, propane. 200 cm cube of propane was mixed with excess oxygen and ignited. Assume all measurements are made at room temperature and atmospheric pressure. Calculate the volume of oxygen that reacted. So here you got volume of I copy this for the reuse. Copy this here. Volume of a gas is given. Which gas is given here? 200 cm cube. Okay, this is 200 cm cube, and it says what volume of oxygen will react. Now you learn this. This is gas and this is also gas. Mole ratio is 1:5, right? And for gases, remember, for only gases, mole ratio and volume ratio is same. If this is 1 mole, yes, this is here 1 mole, then its volume is 24 dm. If this is 5 mole, then its volume is 5 into 24 dm. So what's the ratio of volume? 24 is to 5 into 24, which means 1:5. So mole ratio and volume ratio is same. For that, you don't need to calculate mole, just use the ratio, which is 5 times. Okay, 5 times then 200. 5 times then 200. What do you get here? 1000. So that's the answer of the first question. First question is clear here. This answer is given. It says that 1000 answer. Next question is a very similar question. Volume of carbon dioxide gas produced. I use this relation again. You got here 200 cm cube. You have calculated this 1000 cm cube. And what volume of carbon dioxide to be produced? Look, this is also gas. And mole ratio with the first one is 1:3, right? 1:3. And the volume ratio is same as mole ratio. So what is 3 times of 200? What is 3 times of 200? You get here 600, right? This is the answer of the question. Answer is given. Now the next question, the heat energy evolved during the reaction. This may look little odd to you. This needs knowledge of another chapter, but we still try here. See here, this question. In this question, you get a value of del H. I mean, heat change is given, but this is conditional. This is for 1 mole, right? Understand this? This is 1 mole. 1 mole of what? The gas. If this is burn 1 mole, then you will get this heat only. So these two are related, this heat and 1 mole. Okay? If you don't burn 1 mole, then you won't get this heat, right? So what the volume of this gas given? 200 cm cube. 200 cm cube. This is given in the question. This you are burning this amount. If you divide this with 24,000 to convert this into its mole, what would you get? You may get here. This is 0.00833. Is this there? Let me check. 200 divide 24,000. Yes, this is mole. Okay, mole. And why do I calculate mole? In this question, it says this is now important part. This is 1 mole gives this heat. Okay, so I can write 1 mole gives 2220 kilojoule heat. Okay, this gives this heat according to this expression. And what the mole you have really? 1 mole? No, this mole. If you burn this mole, what the heat you will get? So you can multiply 2220 into 0.00833. You multiply this with what? 2220. Get here 18.49. Okay, this is the kilojoule of heat you get. So this is the answer given in the question. Remember again, I say this person needs knowledge of del H. You don't have that. Maybe because you didn't study the energetic chapter, which we'll learn later, and then this question will be easier. Then this is another question, third question. Two isomers have the percentage of composition by mass. Two isomers. Here are the percentages. Use these figures to calculate, show that the empirical formula of the compound is this. So let's use this figure. We have this, copy this again. These are percentage and we consider them the percentage by mass. We divide all of them with their relative atomic mass. Okay, if I divide them with their respective relative atomic mass, we'll get mole. What do you get for the first one? 24.24 divide 12. I get here 2.02. And what do you get here? 4.04. And what's the last one? Last one, 71.72 to be divided with 35.5. Where you get here? 2.02. Okay, so these are the mole of the atoms we get, and we're going to divide all of them with the smallest one, which is here 2.02. Is that there? No, 2.02. And for this 2.02, and the last one is same 2.02. So what would you get? This gives 1, this gives 2, and this gives what? 1. So what would be the empirical formula? Isn't this now? CH2Cl? How? Because carbon here is 1, right? Carbon is 1. And hydrogen is 2. And chlorine, with the chlorine 1. So this, we get the empirical formula. So this is proved. Clear? Proved. Now, next question is for molecular formula. So we need N, right? We need N to be calculated, and N is the number we multiply in the empirical formula. Okay, so how to get this? Molecular formula mass in this question is given 99. This is given 99. I'm going to divide this with empirical formula mass. This is here CH2Cl. Okay, what do we get? 99 divide CH2Cl means what's its value? 12 plus 2 hydrogens 2 plus 35.5. What we get together? 12 plus 2 plus 35.5. Together is 49.5. So we get here 2. Okay. Now the empirical formula we have already estimated or given. This is what there. And this needs to be multiplied with the number we have calculated. What is that? 2. Right? 2. And what you would get there? This simple 2 here. And if this is multiplied, you get 4. And the last one you will get 2. So this is here the molecular formula. So this is proved molecular formula. And next, question number 4 here. First, read the question carefully. This gram of a metal M. Actually, the M is unknown here, right? We don't know the metal. Was placed in a test tube. You place the metal in a test tube and copper sulfate solution added. Look, equation. Here's the M metal reacting with copper sulfate solution. That's statement we get. And stirred until the reaction is stopped. I mean, the reaction complete. The metal M displaced copper from copper to sulfate solution. Do you get that? Yes, this copper is displaced, kicked out, displaced from the solution. And the copper was filtered or washed with water and dried over oven. Okay, then dried copper was had a mass of 1.27 grams. So copper was estimated. The mass of copper here, look, the mass of copper was estimated to be 1.27 gram, right? And in the question, this is given that initial mass of M, this was 2.38 gram. So these two quantities are given for the experiment. Now get this. Calculate the number of moles of copper that was formed. So this is the first part of the calculation. Question 1. Mass of copper. Mole of copper, right? What is there? 1.27. And this needs to be multiplied with molar mass of copper. What's the molar mass of copper? 60, maybe 63.5 or 4. What do you get? 1.27 divide 63.4. This is 4. What do you get here? 0.02. Okay, that we get here. We also get some zeros. We're not going to write this answer. The answer masses already. Okay. Then another part of this calculation, many students miss this. Hence, the number of moles of M. Look at the ratio. Copper is here, and before this you get 1. And what is before M? 1. Aren't these two equal? 1:1? Yes. So which means M, the metal in this question given the M, this is also 0.02 as the ratio is 1:1, right? Very simple. Next, calculate relative atomic mass of M. 0.02 mole. You got this here. 0.02 mole. You got this here, and this equals 2.38 gram, right? Because initially you got the mass was there of m. This is the mass of m, and this is the mole of m. So these two are equal. So if this is 1 mole, what would be there? 2.38. 2.38 divide 0.02. So let's see here, check. 2.38 divide 0.02. What do you get? I get here 119. Does it match with the answer? Yes. So now, next portion, use the period table to identify the metal. So period table, from the period table you will get that metal is tin, as you will get here in period table 119 to be written this way, which means its mass is 119 and the metal is tin. Okay. Now another question number B here. The mineral kieserite. Kieserite. Don't worry about the word. Kieserite has the formula. It's a commercial name or trade name of this compound. Ore. It's called ore. You'll learn them later. Calculate percentage by mass of magnesium in the kieserite. This is very simple. First calculate mass of the total compound. Okay, mass of the total compound. What do you get here? Magnesium is 24. That you get from pure table. Sulfur is 32, and oxygen is 16 into 4, and then water is 18. I write together 18. So what do you get? If you add all of them together, what do you get? 10 into 4 gives 64, plus 18 plus 32 plus 24, right? Yes, 24. Together is 138. Okay, and magnesium, so percentage, calculate percentage of magnesium. So what is the mass of magnesium alone? 24, right? Divide total mass is 138 and into 100. That would be the percentage. So if I divide this 24 divide 138, what I get here? 0.1739. If you multiply this with 100, what I get here? 17. This I get 17.39. 17.39 means 4. Okay, this is percentage. Next question number 5. This is an experimental question. When hydrated zinc sulfate is called hydrated zinc sulfate. Okay, crystal, solid crystal, hydrated with water, so we call hydrated. Heated. Water is lost. Water is lost. Water goes away, leaving what? The dry zinc sulfate or anhydrous zinc sulfate behind. A sample of hydrated zinc sulfate was placed in the evaporating basin and heated until all the water had been lost. The following measurements were recorded. Mass of empty container. Empty container is this. Only the container. And mass of container, this is the evaporating basin, plus hydrated zinc sulfate. Okay, if you subtract these two, what you do get? What you would get? If you subtract these two, what you would get here? 40, I write 40 minus 0.37. Okay, subtract 34.63. So what's the mass for? 40.37 minus 34.63. It gives you a 5.74. What's the mass for? This is for anhydrous. No, sorry, hydrated. It's hydrated zinc sulfate. Clear? Hydrated zinc sulfate. Because this was mass of the sample and container, and this was only container. If you subtract the container with the container plus sample, you get the sample here. Okay, but this is hydrated. Okay, next. Another information, mass of evaporating basin anhydrous zinc sulfate. Look at this. Here you get mass of two things. Mass of two things. What these two are? The container and dry salt, dry zinc sulfate. And now if you subtract the last first one from the last one, 37.8, what is that from 85, right? 85 minus the first one is the container, 63. What would you get? I first calculate 37.85. 37.85 34.63. Together we get 3.22 gram. What's the mass for? The mass of, look, mass of anhydrous zinc sulfate. Which is this? Mass of anhydrous zinc sulfate. Very clear? Mass of anhydrous zinc sulfate, which is free from water. Anhydrous zinc sulfate. Now, how to get mass of water from this experiment? Which two you multiply? Which two you may multiply to get mass of water? Can you? H2O. How to get H2O? Which two to be multiplied with to get mass of water? The last two, right? Last two. Because this is here container plus water plus zinc sulfate. Remember, container plus water because it's hydrated plus zinc sulfate. And here is this container plus zinc sulfate. No water here. So if you subtract this from this, you would get the mass of water, right? So that we do 40.37. This is the mass of three things. Container, water, and the zinc sulfate. The last one, which is here 37.85. This is the mass of two things, container and zinc sulfate. So subtract this to get mass of water. So what are here 40.37 minus 37.85. I get here 2.52 gram. So we are clear. So you don't need this. You don't need this calculation. So we need this too for the calculation. Calculate relative formula mass of what's that? Anhydrous zinc sulfate. So the anhydrous zinc sulfate add 65.5 plus 32 plus 16 into 4. You will get this. This is answer. So this is very simple. I'm not going to calculate. Mass of anhydrous zinc sulfate was formed. So this is the calculation we already did there. Just copy and paste here. Mass of anhydrous zinc sulfate. And what mass of water loss that we had calculated there. Let's copy and paste here. Get. Now calculate the value of X. Simple, very simple. When you can calculate, you have masses of these two. When you have masses of these two, then the thing is very simple. This is the zinc sulfate. I write here zinc sulfate, and this is the mass of water alone that we need. Okay. So we're going to divide them with their respective molar mass or molar mass. What's the zinc sulfate? There's zinc sulfate according to the first question is 161, and for water this is 18. What the result we get here? 3.22 divide 161, we get 0.02. And for this, 2.52 divide 18, what do you get here? 0.14. So now I divide both with a smaller one. Certainly this is the smaller one. I divide this with 0.02, and that I do for the 0.02. What I get here? 1. And certainly you understand this will give you 7. So 7 is the value of x. This is the answer. Okay, 7 is the value of x. Let's calculate it. Now see the next question. Sulphamic acid. This is called sulphamic acid. The weak acid is used to remove lime scale. And lime scale means calcium carbonate from shower heats. The equation for the reaction is this. So here is this. From shower head, you get here. Calculate the relative formula mass of sulphamic acid. So let's skip this. This is answer will be there, 97. Calculate mass of sulphamic acid needed to remove 1 gram of lime scale. 1 gram of lime scale. Get here, copy again. If this is lime scale, okay, as per the question it says this is lime scale, this is 1 gram, right? 1 gram. And question says what mass of this will require. Okay, so very simple. First we need to calculate here calcium carbonate. It's given as 1 gram. And what is mole? Divide 100. 100 is a smaller mass. Okay. So 1 divide 100. What do you get? 0.01. This is mole. And as per the question, calculate mass of sulphamic acid. And this we can calculate if you have mole, right? You need mole to calculate mass. Then next is this. As per the ratio given in the equation, it's 1:2, right? Isn't this 1:2? 2. So what's the 2? Means double of 0.01. 0.01. This into 2 because it's double. So this is mole. Okay, and multiply with this molar mass. This is 97. What would you get? Into 2 into 97. 97. This gives 1.94 gram. So this is the answer. Very simple. And now another question. This is a little different way. Presentation is a little different, but this is very simple. The Avogadro constant. The Avogadro constant L is the number of specified particles in 1 mole of substance. Avogadro constant has a value. This is actually called 6.02 10 to the power 23, right? Avogadro constant 6.02 10 to the power 23, and that equals 1 mole. But in this question, the value is not given. It's written as L. So you will use L instead of the value. This is the simple fact. For example, a mass of 4 gram methane is this mole. So if you have mass and you can convert into mole, this is the mole. And hence the number of molecules. Listen carefully. If you have number of moles, can you convert this into number of molecules? Yes, mole to be converted easily into anything by multiplication. Multiplying with, if you convert this into a number, you will have to multiply this with Avogadro number. But here Avogadro number is given as L, which means you multiply this mole with L, so this will give this. So this is the number of particles. Suppose this is the Avogadro number. Okay. Now state in terms of L. So calculate similarly with L, not with the real Avogadro number. This, consider this L. Okay. This argon. Argon. So what the mass given here? 20. We cannot convert mass into atoms or number of particles directly, right? We actually need mole. So if you divide this with mole, with molar mass of argon is 40, that you get from periodic table. This is 0.5. Okay, 5 mole. And is this number of molecules or number of atoms? For argon, this is atoms. Number of atoms? No, this is mole. And how to convert the mole into number? For instance, for example, one is given that mole to be multiplied with L, or Avogadro number. So 0.5 into L. So you get the answer. Next question. This is for molecule. This is very simple question, but new presentation. So some of the students get confused whenever they get new presentation. This is a big problem for us. Molecule in 10 gram of hydrogen gas. This is hydrogen gas. This is given 10 gram. Okay, to calculate number of molecules, we need mole. 10 divided 2 is the molar mass. We get here 5 mole. But question is molecule, not mole. So 5 to be multiplied with Avogadro number. But Avogadro number is here L. So this is the answer. Now next, see here the next question. It says hydrogen ions in 1 dm cube of sulfuric acid with this. So here you need mole again. Mole. Mole, without mole you cannot calculate number of particles. Mole equals volume into concentration. Okay, volume into concentration. We'll learn this. What's the volume given? 1. What's the concentration given? 1. What the result you get? 1. This is 1 mole, right? 1 mole. 1 mole of sulfuric acid. So what is sulfuric acid? Look at the formula. Sulfuric acid. Here is another job. The biggest job is still left here. Sulfuric acid. If sulfuric acid is 1 mole, what the mole of hydrogen there? Again, if sulfuric acid is 1 mole, what the mole of hydrogen ion there? Isn't this double? Isn't hydrogen double than sulfuric acid? Yes. So if mole of sulfuric acid is 1, then mole of hydrogen alone is double. Why? Look at the formula again. Formula says 1 mole of sulfuric acid and hydrogen is double mole. So double mole means here 2. But this is not, this is not the answer. You need to calculate the particles to be multiplied with Avogadro number. This is the answer. Next question, percentage by mass. So this is very simple calculation. I'm not going to do that. You know this. And question 8 is another simple question that we need to do here. Simply 63 cm cube of carbon monoxide. Where is carbon monoxide? Here is this 63 cm cube, right? 63 cm cube of carbon monoxide, and reacted with iron oxide. What mass of iron produced? The question says what mass of iron will produce here from this volume. And in order to calculate mass, you need to have mole, right? You need to have mole. How to get this? First, start the calculation with carbon monoxide. There you have 63 cm cube. And if I divide this with 24,000 cm cube, what would you get? 63 divide 24,000. 24,000. This will give you a mole 0.002625. It's a mole. And iron. The ratio is not very simple. Look at this. 3:2. 3:2. So how about iron? Can you estimate from this ratio? There's 3:2. So if this is the mole of the 3, which is a 3:2, as per the 3:2, this is what would be the mole of iron? This to be multiplied with 2 divide 3. Okay, multiply 2 divide 3, that's the ratio. 2 divide 3, yes, into 2 divide 3, I get here the mole 0.00175. Okay, this mole. But question says about mass. No problem. Multiply this with mass of iron is 56. This is as per the 56 or 57? 56. So multiply with 56, get here answer. It shows 0.098 gram. Something is wrong here. Something is wrong. The answer doesn't match with, right? Right. Oh, I got the reason. I got a mistake here. This was given dm cube, not cm cube. Okay. If this is dm cube, you have to multiply with just 24. Okay, not 24,000 cm cube. And then 63 divide 24, this gives 2 point something. So decimal will be, the point will be here, and this will be here. Accordingly, all the answer will change. This 1 point something multiplied, you get here 98 gram. Okay. With slight mistake, we get answer wrong. Now this question, 25 cm cube of butane was mixed with excess oxygen and exploded. This question, volume of, oh, this question is repeated here, right? We already solved this question previously, so we're not going to do this now. Now question number, this you get here, question 10. Question 10, you need to calculate the value of x. See here, copy paste, and this too we have. It says this gram hydrated compound. So this compound is not alone sodium sulfate. You need mass of sodium sulfate alone and mass of water alone to convert them into their mole. But the mass given here together. No problem. Remove water of crystallization and loss of a mass of this gram was found. So when you heat, this gram mass is lost. What is lost? Lost is water. So this mass is of water. You need to understand the language. This important issue. When this mass was lost, so certainly there's mass of water. If you don't understand this language, then this is a problem. Look, the together mass was this, and water alone is this. So you can calculate simply, very simply. This is 6.44. Together mass and alone water is 63. Okay, 60. So what do you get here? 6.44 minus 3.60. We get here 2.84. And here's that. And you need to divide this with its molar mass. Molar mass is not given, so we need to calculate the molar mass. Okay, this is 18. Its molar mass is 18. And what's the mass, molar mass of sodium sulfate with which we divide? So sodium is 23. This is into 2 because there's 2 sodium. Sulfur is 32, and oxygen, 4 oxygen is 64. 4 oxygen, remember. 4 oxygen is there. And what we get here, I write 23 into 2, this gives 46. 46 plus 32 plus 64. Together is 142. 142. 2.84. Divide 142. That was the 0.02 mole. And what do I get here? 3.60 divided with 18. I get 0.2. So which one is smaller? Certainly the first one. So divide both with 0.02. 0.02. I get here 1. And for the last one, 10, right? Isn't this 10? Divide 0.02. Get 10. So that's the value of x is 10. That's the answer of the question. Now another similar question, very not this different question. Okay, this gram 2.5 gram of pure zinc was added excess amount of hydrochloric acid. The salt produced was evaporated. Salt is that. This is the salt produced. The amount of the salt was this. Okay, this was this. Calculate maximum mass of zinc chloride to be produced from this experiment. Look carefully. We use the equation. This is the equation. It says you have this gram pure zinc, right? This gram pure zinc. You got the pure zinc, and at the end you have got this zinc chloride 4.97, but this mass is experimental, right? Someone has carried out this experiment and got this result. So we convert this into mole. 2.5 divide 65.5. What is that? 2.5 divide 65.5. What do you get? Equals 0.0382 is the mole we get. And as per the equation, mole of zinc chloride should be same, right? What is that? 0.0382. So this will be the mole of zinc chloride for the equation, the same ratio. And this is zinc chloride multiplied with molar mass of zinc chloride. This is 65.5 plus chlorine is 35.5 into 2. So what do you get there? The mass. Okay, 35.5 into 2, you get 71 plus 65.5, 136.5 is to be multiplied with the mole 0.0382. I get here 5.21 gram. So this is the mass. Okay, you get mass, maximum mass. And percentage of yield means you have practical yield. Practically you got the same product. This is there, this was there. Okay, this you have got there experimentally. Someone carried out experiment, got this. And theoretical mass that's supposed to get 5.21 and multiply with 100. We get the percentage. This gives 95.4. So that's the answer. And another question there. This question is not difficult. This is easy question, but with the big language, big statements, some student may think that this is a very difficult question, right? But question is simple, and we're gonna finish this with this today because it's been long. An ore of copper has the formula this. Listen carefully, you will find this is very easy. And this was here in the test tube. in the experiment, heated. When heated, two gases are produced. One is carbon dioxide, another is steam. Okay, these two gas leave the test tubes. It says that the first U tube, okay, the first U tube filled with calcium chloride, this will absorb one of the gases. Which gases will this absorb? The first test tube will, first U tube will absorb water, right? That it says the ore was heated and two gases were passed through anhydrous calcium chloride as the first U tube. This will absorb water. Remember, this will absorb water. So won't its mass increase? Yes. Why? Because this will absorb water. What mass of this increases? See, increase in mass, this. So isn't this mass of water? Isn't this mass of water? Because this is an increasement because of absorbing water. So when this absorbs water, this mass increases. So this is totally mass of water. The next one, increase in mass of potassium hydroxide. Potassium hydroxide absorbs carbon dioxide, the other gas. So this is the mass of what? Carbon dioxide. Clear? So use the mass to calculate xy. This is a very, very simple calculation. The values of xy as per the percent it says. So you get here, first I can write carbon dioxide or water, anything I write first, no problem with H2O. What the mass of carbon dioxide? Carbon dioxide mass, this is. This, if you understand language, then many things are very simple. Many questions are very simple if you understand language. So this mass was due to absorbing water. So this mass is totally mass of water, 0.72. Is this a difficult fact that you estimate masses of these two? Very simple. Just problem is the language. So when we divide both of them with the respective molar mass, this is 44 here and 18 here, what do we get? 0.88 divide 44. This gives 0.02. This is a very common answer we get several times. The next one is 0.72 divide with 18, 0.04. Now convert them into the round figure. We can multiply them, both of them with 100. Or still you can divide with the smallest one, as we do very commonly. We can multiply both of them with 100 to get the simplest ratio, or divide with the smallest one, 0.04. What do you get here? Something wrong here. Should divide with this, not with the big one, right? So what we get here, 1, right? What we get here, 2. So look at the formula. Look at the formula there. X carbon dioxide, right? And here is X copper carbonate. X copper carbonate. And here you get X carbon dioxide. So X is carbon dioxide. What is that? 1. So it's the value of X is 1. The value of X is 1. And Y? What's the value of Y there? 2. Okay, before water in the equation, go to the equation Y water. And the next question, use the values of X, Y to rewrite the formula. That's the next question. So this is very simple. Here is X. We don't write X because it's 1. Here was Y. We don't write Y. We write 2. This is here. This is here. We put the values of X, Y to write the formula. Okay. And percentage by mass, I'm not going to do this, or I'm not going to show you any more calculation because all are very similar. All are very similar. So thank you very much. Try yourself the remaining few others, and so far we have shown many of them. If many of them are understood well, then few others you do yourself that you have to do. Thank you very much.